Now let's do the next question. This is integral dx over e raised to the power of x, positive e raised to the power of negative x. This question was asked at Bihar CEE 1976 and MNR 1974. Now don't be intimidated because it is 1974, 1976. Remember, always these particular, or I should say questions like this, they keep repeating in competitive exams. So if it is 1976, then there is a high likelihood of this question reoccurring. So better to get prepared with all these questions. Now this can be rewritten as integral dx over, I'm going to write e raised to the power of negative x as 1 over e raised to the power of x. Now this can be simplified as dx over e raised to the power of x times e raised to the power of x. I'm taking e raised to the power of x as LCM. So I would be getting e raised to the power of x times e raised to the power of x, positive 1. I can flip this, so this would be e raised to the power of x times dx divided by e raised to the power of x times e raised to the power of x is going to be e raised to the power of 2x, because a raised to the power of m times a raised to the power of n is a raised to the power of m positive n. So this is going to be e raised to the power of 2x, positive 1. Now this can be further rewritten as e raised to the power of x raised to the power of 2, positive 1. So I'm going to make a fancy substitution. Let e raised to the power of x be equal to some t. I differentiate, I get e raised to the power of x dx is equal to dt. So this is equal to, in place of e raised to the power of x dx, I'm going to substitute this dt. And in place of e raised to the power of x is t. This has got an exponent 2, so place that. Now this is nothing but tan inverse of t. You don't have to place a constant here. Replace t with e raised to the power of x. So this is going to be tan inverse of e raised to the power of x plus arbitrary constancy. So that would be the solution for this particular question. So we'll move on to the next one.